How's it going, everybody? I don't know if this is working. Okay, cool. So my name is Aman. This is actually my first time in LA. I'm originally from Cincinnati. I came down here for this talk. Sorry? Oh, thank you. This is awesome. I did not know it was going to be this many of you guys. I thought it was going to be like 20 people, the usual case, but this is awesome. So, like I said, my name is Aman. I studied physics at University of Cincinnati. I now work for this company, Datazar. And before I get into D3 and the awesomeness of D3, I want to talk to you guys about what we do a little bit so we can get a little context. So Datazar is a research collaboration or data collaboration platform. We allow people to upload data, analyze it, make visualizations, stuff like that, and then share it back to whoever uploaded the data. So you can kind of see context. And I guess this is not working. Is it me? Okay. Can you guys hear anything now?
Yeah, just put it higher.
Yeah. How about now? I'm just going to hold it. You got it? Now? Good? Good? Good. Oh, awesome. Okay. All right. Which part should I re-say again? I'm just kidding. So Datazar, a research collaboration platform where we allow people to upload data, or share it back, make visualizations in D3 and stuff like that. So you can kind of see how a data evolved from the beginning. So it goes from raw data set to being prepared, to being analyzed, to being visualized, and then share back what you found. And the whole idea was, are people going to get the same results if they use one of the same analysis platforms, if they use the same methods, and what's going to be the difference at the end, right? And so the whole reason we kind of started was the whole research process now was completely messed up, right? Especially because it's very old school, I'd say, for us a little bit. So you do your analysis. Yeah, I mean you do your data collection. You analyze it, whatever, from a network analyzer or whatever it is. And I'm going to be really physics specific here, just because that's what I know. You do that, and then you analyze it, you visualize it, and then you send it to your advising professor, whoever it is, your team, through email, and then you upload it to Dropbox. And then at the end, you finally share it. But then in the middle, you've completely lost a lot of things, all the context, how you went from point A to point B, what methods you use, unless you specifically specify that in whatever you're sending, right? And so we said, okay, let's make this very simple. You upload your data through either an API or interface, and then you collaborate, decide where you're going to analyze or whatnot, and then you analyze it using whatever it is, showing all the steps that you're taking, and then finally share it. And then if somebody else sees it or somebody comes in the middle of the research project, they can see exactly where you left off, what you've done to get to that step, right? So we wanted everything to be in line. All right, enough about that. And then at the end for us was, if somebody used this data, let's say for example, somebody used temperature data from NASA to work on global warming, that's actually one of the projects we're working on. And somebody else uses it for economics, and somebody else uses it for healthcare, somebody else uses it for whatever. We wanted to see how these different topics related to each other. And it's really interesting. You can see some topics are closer than you think, even if you did not look at the data, right? Economics might be really close to physics or do whatever. All right, if you guys go to here, you guys can see all the data. You don't have to sign up. I'm just going to skip that. Okay, so D3. The reason we started with D3 was when people were uploading data, they were leaving the platform a lot of the times just to analyze this data, and then they would come back, and then they would lose a lot of stuff in between. So we said, okay, what would it take to let people analyze data on our platform? Obviously, the obvious answer first was Jupyter, right? Jupyter Notebooks, Python, and R. But we said, okay, how about we use JavaScript? So that can kind of give us a kick, and everybody knows JavaScript. It's really out there, and D3 is really awesome. So we said, okay, let's do that. Let's work on JavaScript. But the problem, right? Oops. The problem was a lot of these D3 analyses that were being made were kind of one-off, right? People would make them, write hundreds of lines of code. If you wanted to use that same thing for your own analysis, it would not work, right? It's very, very project specific. So we said, how about we abstract it a little bit and let people use each other's code, right? And there was this wonderful thing, right? We create our own programming language and we say, okay, we're going to let people abstract D3 modules, and then we're going to let other people code those modules and match it with whatever data they're doing, right? So we said, people will be able to write, point plot function, and then you will get somebody else's data on the platform, and then you can plot that in real time while you're on the platform. So our whole thing was people should not be leaving our platform to do whatever they're doing. So this is kind of what it looked like. This is a kind of a mix. We abstracted it a little bit in the beginning as well. This is kind of a mix of raw JavaScript and D3. So people would make this module. They would write it on our platform using D3, which is already included as a library. And then you can even test it as a test file here. And then somebody would call that function from our platform, right? And I'll zoom in here a little bit for the code. So our code was very, very, very simple. I wouldn't even call it a programming language. It was more kind of like these commands you would send to get back these outputs. So you would say, okay, I want to visualize this data set, and here's this, and I want to use this D3 code, specific code. If you see there, the line plot, there, is that you or me? The line plot function, I would say, okay, my username, and then the line plot function, and then that would plot me whatever this is, right? This is just a random numbers being visualized. So we got a little bit more complex. People were building these modules, and then you would call them. And then the biggest problem came. People had to learn how to write a new language, and people had to know how to make D3 modules. And so this was a complete failure, right? People were not making this. They did not want to learn a new language. They said, okay, why not use R? Why not use Mathematica? Why not use MATLAB? We just wanted people to stay, but they wouldn't. And so what we did now was we said, okay, that did not work, so how can we still let people use JavaScript and still be able to plot data on our platform, right? And so we went more into templates instead of using our own language. So let's say, for example, you take this raw data set. This is a temperature data we got from NASA. Here's the expanded view. And then we said, okay, even if it's horrible, let's just let people write hundreds of lines of code to analyze this data set. So here's that, just to plot this function, this data, right? That's just 1 month. You would have to write all of that just to do one thing. If we did it in our own programming language, all of that would be abstracted for you. Only thing you need to do is just give it that pointer to the file, and then you would just plot it automatically, right? But that didn't work still. People did not want to learn the language. Here's another one. Here's another templated function here. This is plotting each month of the same data set. And this is kind of where we want to go at the end of the day, is people are not leaving the platform, that you're just doing it in real time on the platform right there, right, without having to leave anything. And then you're still at the same time showing people how you did it. People can see your source code, they can see what data point you use, you can see how you analyzed it. Because a lot of the times when you're doing, especially computational stuff, you want to see under the hood of that mathematical function, right? What is that actually doing? Does that differ from platform to platform, right? Especially when you get to higher numbers, if you want to get more accurate, to what extent is it approximating and stuff like that too. So our whole vision is, if people can see more and more of the code, they can see under the hood, they can see under the hood of the functions, would it be better for the whole community, right? Will it be better if you can see for how I got from point A to point B? And there's a huge culture of just showing the end results and not showing what you've done before. So we kind of wanted to get rid of that. It's a huge, huge problem, and we're not going to be able to fix it anytime soon, but we think this is a good start. Here's another one. And so when you save these files, you can see exactly how somebody did it. And they're saved just like any other file. You can download this file just like any other file you would in a platform. And so here's another one. So a few weeks ago, a few months ago actually, somebody uploaded where every meteorite has hit in the world since like the 1700s. We got that data, we plotted it using D3, and this is kind of what we want happening on a bigger scale, right? I upload some things, everybody else goes on the platform to analyze something, and then we would get back results. Can we match this with something else, and can we predict stuff? Can we see that how this has affected something else, right? This is kind of the bigger picture of our whole thing. But again, I kept saying like we want to go back to JavaScript. That's just because everybody knows it and it's more comfortable to write in, I think, at least. We will be supporting Jupyter just because it's a really high demand right now for us, and R as well, and B, writing SDKs for all these other languages. But this is another example of using D3. And all of this is open and open source. You guys can go check it out. So next we'll be integrating Math.js. I don't know if probably one of the creators here. Math.js and D3. So we want to not only just visualize, because visualizations are just literally the end of what you do in a research process. You have to do all the computational, all the analysis, all the cleaning. So we kind of want to integrate that, expand it a little bit, and see if we can do a lot of the computational stuff also before we get to the visualizations. Right. That's it. And here's my contact information if you guys want. I'll open up for questions in a little bit and talk a little bit more. But so far, is there any questions? No? That's first. Good. Oh.
What about animation?
Animation?
Yeah.
Yeah, I mean, do you mean if we support it?
Yeah.
Yeah, I mean, anything you write, so I actually didn't show it because it's PDF, but anything you write here will be displayed if it's animation or whatever it is. Yeah, we'll display everything. At some point, we're going to have to start checking what kind of code it is just because it's a little disruptive sometimes. But yeah, anything is supported as long as your browser handles it. Yes, any questions? Yeah. Oh, the sign up URL?
Yeah.
This. Any more questions? Guys, any questions? Yeah.
What are some of the most interesting things that you've seen people use through the platform? Or what have you seen that do?
Interesting. So whenever we release a data set, the most common thing we see is just people analyzing a data set differently using different platforms. So we usually see somebody do it in R, somebody do it in Python. Usually they look like the same results, so it's just people using different platforms. There's also animations and stuff like that. We've just kicked this off about 2 months ago, so we haven't seen that much, but it's pretty good. We haven't pushed out a lot of data, but a lot of the data we have is, so we have Olympics data, all the data from NASA, City of Cincinnati, Ohio, and stuff like that. We haven't come here yet. We will. Questions? No? Cool.
All right, give it up for Aman.
Most all of the 10 secrets to writing perfect code that I'm going to tell you tonight have previously been covered at JSLA. So here we go. Number 1, practice. Practice, practice, practice. Just like everything else in life that's challenging and rewarding, you need to practice. So you can practice with online tools like Node School, or you can attend the upcoming Node School, or you can do things like HackerRank. You can also work